So let's talk about scalar and vector. So what is scalar? Scalar quantities are quantities that has magnitude, unit only, while vector quantities are quantities that has both magnitude, unit, and direction. So for scalar quantity, we are going to have magnitude only. While for vector quantity, we are going to have magnitude and direction. Now let's talk about some physical quantities and where they fall to. Let's start with time. Is time a scalar quantity or a vector quantity? The fact that we can have 10 seconds to the east, we can have 30 minutes right, we can have 40 seconds to the west. Therefore, time is said to be classified under scalar quantity. So time is a scalar. Now, what about distance? What exactly is the definition of distance? Distance is the space, gap, or length between 2 points. Now, we will observe that we didn't mention anything like direction. So therefore, distance will be classified under scalar quantity. So distance is a scalar as well. Now, what about displacement? From the definition of displacement, we should be able to tell whether it is a scalar or a vector. Displacement is the distance traveled in a specific direction. So when we are having 3 meter east, when we are having 3 meter to the right, when we are having 4 kilometer westward, then we are referring to displacement. As soon as direction is being associated, then it is displacement. So therefore, displacement falls under vector quantity. Now, what about speed? What exactly is the definition of speed? Speed is the rate of change of distance. Now, we can also use the formula of quantities to check if either they are scalar or vector. Now, we'll observe that we said speed is the rate of change of distance, and the formula for speed is distance over time. So we are still having scalar quantity dividing scalar quantity. Then the result will definitely be scalar quantity. However, we can also see it in another way around. When we have 5 kilometers per hour without no specific direction, then we are referring to speed. But as soon as we are having something like 5 kilometers per hour east, 3 meter per second west, then we are referring to velocity and not more speed. So that makes speed to be under scalar quantity. So speed is a scalar quantity. Now, just as we have said, we said when we relate or when we associate direction with 30 kilometers per hour or 3 meters per second, we are referring to velocity and no more speed. And we said vector quantities has magnitude and direction. So therefore, velocity will fall under vector quantity. So we have velocity to be under vector quantity. Now the next one is mass. Can we have 5 kilogram waste? Can we have 30 gram knots? Can we have 10 kilogram waste? So as soon as we can have a direction being associated with mass, then mass is definitely a scalar quantity as well. Now, what about acceleration? Is acceleration a scalar quantity or a vector quantity? Just as we have said, we can use quantities formulas to check if either they are scalar or vectors. What is the definition of acceleration? Acceleration is the rate of change of velocity. Acceleration tells you how your velocity changes with how fast your velocity changes with respect to time. So it means you can accelerate towards the left, you can accelerate towards the right, you can accelerate towards any direction. And we said is the change in velocity over time. We are having a vector quantity dividing a scalar quantity, which is going to result in a vector quantity. So it means acceleration is a vector quantity. To stop. So the next quantity should be temperature. What is temperature? Is the degree of hotness or coldness of a body. Now, can we have anything like 30 degrees Celsius west, 5 degree Fahrenheit north? As soon as you can't have anything like that, temperature is also a scalar quantity. Temperature. Is that the spelling? Temperature. Okay. Is it T? Okay. You guys should not use me to laugh. So we have temperature to be a scalar quantity. So what about force? Is force a scalar quantity or a vector quantity? We said force is the product of mass and acceleration. So we are having a scalar quantity multiplying a vector quantity, and our result will definitely be equals a vector quantity. So force is definitely a vector quantity. So let's check it in other way around. If I should pull an object, the object will definitely move away from me. Why? If I should pull an object, rather, it will definitely move for. So as I was saying, if I should move or if I should push an object, the object will definitely move away from me. That is, it will move to the direction whereby I apply the force to. Why? If I should pull an object, then the object will definitely move towards me. That is, it will move towards the direction of the force being applied to the object. So that makes force to be classified as a vector quantity. Now, what about momentum? Is momentum a scalar quantity or a vector quantity? We said momentum is the product of mass and velocity. Now, we said it's all about collision. Now, let's say we have two bodies tending to collide with each other. Now, let's say one body has a higher mass than the other, and at the same time, this body is moving with a great velocity higher than the other. Now, when they collide, the one that is lesser will tend to be moving in the direction of the one that is higher. So therefore, that makes velocity to be a vector quantity. And at the same time, we can use the definition of momentum as well. As we said, is the product of mass and velocity. And we said when scalar quantity is multiplying vector quantity, the result is going to turns out to be a vector quantity. So therefore, momentum is a scalar vector quantity. So that is how to figure out whether if a physical quantity is either scalar or a vector quantity. So you can use either the definition of the particular quantity, or you should use it as I just used it. So that is the basic idea behind scalars and vector quantity. So please, if you haven't subscribed, make sure you subscribe to my channel. So, and don't forget to give me a thumbs up as well. So see you guys in the next video. Thanks for watching.